Our second set of problems involving sequence of IID Bernoulli trials ask similar questions but in a different context. So let's just spend a minute reading the question. Okay, so as you see, the success probability is 0.05 per trial. Let's look at the first question. If you want to work through it, please pause the video. Otherwise, let me start going through the solution. So this is a direct application of the geometric CDF. And if you work through the numbers, it's 0.045, the probability that the first success will occur on trial number 3. The second question also is a straightforward application of the geometric random variable. We are looking for the mean of the geometric random variable, and that, as we know, is 1 divided by p. So the expected number of trials to success, the first success would be 20. The third question again is to do with a geometric CDF, and if you work through the algebra and round it off, the answer would be 45. So 45 trials would be needed. Now question number 4, part D, that also is an application of the geometric CDF, that 10, 11, 12, all the way up to 30 trials would be needed for the first success. So we are looking at the difference of the geometric CDF. So since it's 10 or more, so we have to take the difference of the CDF at 30 and 9. So the CDF at 30 and the CDF of 9, if you take the difference, the answer should be about 41.5%. The next question is different because the number of trials is fixed. So it's no longer geometric, but it's a binomial random variable problem. And what we are interested to know is that 2 or more of these 10 trials would be success. So just simply plug in the binomial PMF, and the answer is, it's better to look at the complementary event, that 2 or more. So we subtract the probability of 0 and the probability of 1 from 100%, and the answer is 0.086. Now, it does matter that if at least one hit is known to have occurred, so it does change. It's now a conditional probability. So the numerator is still 2 or more hits because it's the intersection, and the denominator is 1 or more hits probability. So the numerator is still 0.086 as we found before, and in the denominator we put the probability of 1 or more hits, so it's 1 minus probability of no hits, so the final answer comes to 21%. The next problem is being a little more specific, that it's not that we want 2 hits in 10 trials, but we want the second hit on trial number 10. So this is the negative binomial distribution problem, and if you just apply the PMF, you get the answer of 0.0149. The last question is looking at the complementary event. So the second hit can occur anytime, 10th or later. So we are not interested that it happens on the 10th only. So it's better to look at the complementary event. So the equivalent statement is in the first 9 trials, either 0 or 1 success will occur. So let us just then add the two. So the probability of 0 hits in 9 trials and the probability of 1 hit in those 9 trials, if you add the two, you get a probability of 92.9%.